Countdown. All right, so there were a few examples that we found the characteristics for in the video notes. We're going to do those first. So looking at example A, we always factor first. We saw that there weren't common factors in the numerator and the denominator, so there isn't a whole. Next, we move to the vertical asymptotes. And I mentioned this in the video notes, but be careful, you guys. It's not a solution set. I'm not saying that x equals 0, comma, -2. We have to write each of the asymptotes as individual equations because they're each their own line. So for our vertical asymptotes, we have x equals 0 and x equals -2. Next, we found that the horizontal asymptote was y equals 0 because the numerator had a smaller degree than the denominator. There wasn't an oblique. The x-intercept, again, in the video notes, we noted that we would approximate when the time came. Ha-ha! The time has come. We need to graph and plot these points. So rad 2 over 2 is approximately 0.7. Okay, if you haven't added that onto your notes, go ahead and adjust to that so you know we can graph it. And there isn't a y-intercept. Alrighty, let's go ahead and graph our characteristics before we journey into actually sketching the rational function. We have an x equals 0 vertical asymptote. Please make sure that these are dashed lines. And x equals -2. There's a horizontal asymptote at y equals 0. Also a dashed line. Uh-oh. I have an x-intercept on my horizontal asymptote. Is that okay?
No.
Why not?
Because I can't cross.
I can't cross a horizontal asymptote?
Never mind.
No, that's okay. I appreciate you participating. Can I cross a horizontal asymptote? Yes. What's the one asymptote you cannot cross? Vertical. Good, everyone. So even though we have a horizontal asymptote on the x-axis, it is okay for us to have x-intercepts there as well. Okay. This is where the uncertainty comes in because we don't have points that we can transform and graph. We're not even going to find points that we can plot. What we're going to do is sketch in the rest of the function. So how do we do that? I need to figure out where the graph is in relation to the x-axis. So I need to figure out, does the graph exist up here or down here in that region? In between the next vertical asymptote and the x-intercept, does the graph exist above or below the x-axis? In between the two x-intercepts, does the graph exist above or below? We need to figure out where the function lies in relation to our characteristics. Now, question for you. If I'm above the x-axis, are my y values positive or negative? They're positive, right? If we're below, are they positive or negative? The y values? They're negative. So in order for us to sketch our rational function, we're going to create a number line that represents our x-axis and see where the graph is in relation to that. Okay? So do me a favor, please, and draw a number line with me. And the only characteristics we're going to put on this number line are vertical asymptotes and x-intercepts. We're never going to put our horizontal asymptotes. We're never going to put oblique. Just vertical asymptotes and x-intercepts. If you think you'll forget that, you should write that down. I'll say it one more time. The only characteristics we're going to put on this number line are vertical asymptotes and x-intercepts. Why? Because it represents our x-axis. So looking at what we have from left to right, the first characteristic we have is a vertical asymptote at -2. Then we have an x-intercept at -0.7, another vertical asymptote at 0, and an x-intercept at 0.7. Now, if you need to or want to, you can always sketch in what these represent so that it's a little bit easier for you to make the connection between your number line and the graph. Just a strategy suggestion. You don't have to. And let's start testing. What we're going to do is we're going to find a value that we can substitute in for x in each of these regions to find out if the corresponding y value is positive, meaning we're above the x-axis, or negative, meaning we're below. So in our first region, what would be a good value to substitute in for x? What's a number less than -2? -3. I love it. Let's do it. And we have two options. We could use the original version of the function or the second one where we factor the denominator. It doesn't matter, okay? I'm going to use the first one. So I have y is equal to -2. I'm substituting in -3 for x squared plus 1 over 2 times -3 squared, cubed. There we go. Plus 4 times -3 squared. Again, we're only looking for the sign, not the actual numerical value. So, in the numerator, what is -3 squared? 9, okay, but 9 times -2 gives us, and if I add 1, do I end up with a positive or a negative number?
Negative.
You end up with a negative, right? So in the numerator, we're going to have a negative number. In the denominator, what is -3 cubed? -27. And then we multiply that by 2. Okay, so we've got a pretty big negative number. But -3 squared is 9 times 4 is
36. It's still negative.
It's still going to be negative. Excellent. Well, if I have a negative divided by a negative, what do I have?
Positive.
Excellent. You have a positive. So in that first region, our y values are positive. They're above the x-axis. So I'm going to put a plus above the x-axis to show where my graph should be located. The next region is -2 to -0.7. What's a good number we could choose for x in there? I love it. Let's do -1. Okay, so for that second region, we have y is equal to -2 times -1 squared plus 1 over 2 times -1 cubed plus 4 times -1 squared. In the numerator, are we going to have a positive or a negative number?
Negative.
Okay. What about in the denominator? Positive, good. So what is a negative divided by a positive?
A negative.
A negative, excellent. So in that second region, our y values are negative, meaning that the function's below the x-axis. All right, third region, between the x-intercept and the second vertical asymptote. What's a value in between -0.7 and 0?
Negative 0.5.
I love it, -0.5, perfect. Let's do it. So y is equal to -2, and I'm going to use a fraction, so -1/2 squared plus 1 over all right, in the numerator, is it positive or negative?
0.
Mm-mm.
No, it is negative.
Well, what's negative 1/2 squared?
1/4.
1/4 times negative 2
Negative 0.5.
plus 1.
So
So is the numerator positive or negative?
positive.
Should be positive. Excellent. What about the denominator?
Positive.
Positive. Very good. So if we have a positive divided by a positive, we have positive. Now, if your number sense is struggling and you're not really sure how we're coming up with these numbers, can you use a calculator for the time being? Yes. You will not have one on the test, so don't get comfortable with the calculator. But for now, you can. All right. What would be a value in between 0 and 0.7?
1/2.
1/2. All right. So for that fourth region, let's take y is equal to negative 2 times 1/2 squared plus 1 all over 2 times 1/2 cubed plus 4 times 1/2 squared. What's the sign of the numerator? Positive. What's the sign of the denominator?
Positive.
What's positive divided by a positive?
Positive.
Positive. So in this fourth region, yet again, our y values are positive, making our function go above the x-axis. Do you need what out? Oh, here. Last but not least, what's a number greater than 0.7?
1.
1.
That's simple.
I like it. Simple is nice. So y is equal to negative 2 times 1 squared plus 1. What's the sign of the numerator?
Negative.
Denominator.
Positive.
What's a negative divided by a positive?
Negative.
It is a negative. So in that very last fifth region, our graph is going to be below the x-axis. All right. Whew! Things to think about as we head into sketching. Number 1, your horizontal and oblique asymptotes guide the end behavior. Number 2, you cannot cross a vertical asymptote. Number 3, any intercepts that you have found must be included in the sketch. Your graph must include them. Okay? Here we go. Region number 1 says that we are above the x-axis. So, I'm going to start at the horizontal asymptote because it's guiding my end behavior. And as I draw my graph from left to right, I'm going to have to curve up because I cannot cross that vertical asymptote. Okay, I started at the horizontal asymptote, and then I extended to the right, curving up because I cannot cross the vertical asymptote. Mark.
Does it matter where we start, like horizontally? Does it?
You must start close to the asymptote.
Okay.
Yeah.
It doesn't matter if it's like 0.3 or 0.4. It just has to be relatively close. Then you can
Oh, gotcha. Yes.
Okay.
Relatively close. Thank you. Sorry for the confusion. In the second region, we are negative, which means our y values are below the x-axis. So I'm going to start at the vertical asymptote because I can't cross it. And I'm going to extend up because I need to include the x-intercept. In the third region between the x-intercept and the vertical asymptote, our y values are positive. So that means we go above the x-axis, getting close to the vertical asymptote but not crossing it. In the fourth region, in between the second vertical asymptote and the second x-intercept, we're above the x-axis. We have positive corresponding y values. So I'm going to start by the vertical asymptote, and I'm going to go down towards the x-intercept. Where do I go from here? Down. We go below the x-axis. So I'm going to go down, coming back to end at my horizontal asymptote. Why? Because the horizontal asymptote guides the end behavior. We can't shoot down to negative infinity. We must end at this horizontal asymptote. Now this curve right here, it can be really low as long as you come back to the horizontal asymptote. It can be really tiny as long as you come back to the horizontal asymptote. We don't know the depth of the curve. That's not what matters to us. What matters is that we have graphed in the correct region, either above or below the x-axis, and we're adhering to the purpose of all of the characteristics. Does that make sense? Okay. For the domain, what do you think is going to restrict our domain for this particular graph? Yeah, who said that? Nice, thanks, Chloe. That one. The vertical asymptotes. Anything else? Or just the vertical asymptotes? Just the vertical asymptotes for this one. So let us say that the domain is all real numbers except x cannot equal -2 or 0. If you're trying to get more comfortable with interval notation, hopefully, we're going to go from negative infinity to -2, non-inclusive, union, -2 to 0, non-inclusive both, union, 0 to infinity. Now, for the range, it's really, really important that your range matches your sketch. We will have differences between the two, yeah? We will have differences between our sketches at times. Did I go lower than Dylan? Did Mark's curve go higher than mine? Your range has to match your sketch, yes? So looking at my sketch, what would my range be? Who said that? Why? In which section? All three? Where? You're correct, but there's one particular reason why it would be all real numbers. Max?
Where the cube function is.
That middle piece, right? Since that middle piece, nice job you two, goes from negative infinity to positive, does it matter what the other two were doing? Not at all. So, since that middle piece goes from negative infinity to positive infinity, we're going to say that our range is all real numbers. Or negative infinity to positive infinity. All right, any questions on A? Mark.
So if my curve were to be a little lower in the third section, would that change the domain?
No.
No, okay.
Andrea?
Why is the middle one different from the other ones? Why is it not shaped?
There isn't a blueprint for what the shape's going to look like. It all depends on how the y values fall in relation to the different sections and then what the characteristics are. So that middle section, the first piece, our y values were negative, and the next one was positive. So there wasn't any other option than for us to go from down to up. I know that probably doesn't help, but does that help a little bit?
Yeah, and you can't cross the vertical asymptote, so it happens up.
Exactly. Good. Thanks for your questions, you two. Max?
We're usually going to have not just 3 pieces, we're going to have either more or less, right?
You could have just 2. You could have 3, you could have 4. It depends on how many vertical asymptotes you have. Yeah, Mark?
If it's 2 and we took the range from the middle, how do we find the range for the 2?
But you'll see in our next 4 examples.
Oh.
Yeah, great question, but pause on that for a sec. Thanks, everybody. All right, let's take a look at B. I feel like A is the most intense example, and it's our very first one. So here we go on B. We have to first factor